Hello everyone, welcome to the channel. So today we will be solving this problem of the day in LeetCode. Today is 21 Jan 2026. This problem statement is actually the same as the yesterday's ones, uh, but the constraints are a little bit high over nums of I. If you remember previously, we had, uh, for nums of I, we had the constraints like it was less than equals to 1000 and it was greater than equals to 1. So, and also num dot length, it should be nums, and also nums dot length was up to 100. So, so yesterday's solution's time complexity was big of n times 1000. So, which was basically 1e5, which got accepted. But now for this problem, the part two, this constraint is now 1e9, so we cannot directly, submit the solution of n times 1e9 because it exceeds 1e8, right? So we want to find an optimal answer, right? So I think the problem statement is self-explanatory. It should be clear to you. So we are given an array. For each element, we have to find x such that x or x plus 1 gives us that number. Okay, ai for this is for all I in the array size. So now if here we want to optimize this answer, right? So as we saw in the yesterday's solution, like for 2 the answer is never possible. So it is true for this problem as well because the statement isn't changed, right? So for 2 the answer will be always -1. Okay, now let's talk about the other things now. We are given that nums of I is prime, and we saw yesterday also that except 2 everything will be odd, right? So it will be 3, 5, 7 or 11, 13, 17, right? So everything will be an odd number. That means that uh, in the binary representation of this every number, there will be a 1 at the last. Like for 3, the binary is 1, 1. For 5 is this. For 7, it's this. For 11, it's this. For 13, it's this. And for 17, I don't know. Is this the one? Yeah. 0, 1, 2, 3, 4. Yeah. Okay. So now, as you can see, there is the last bit of every number is set, right? So what we're gonna do is basically, okay, so we can say that there will always exist an answer because we can always, unset this bit. That means which will just subtract 1 from the current number. So I'm saying that for every AI, the answer, the at least the least answer will be, the maximum answer will be AI -1 or AI. As we want to find out, x or x plus 1 should be AI, right? And this will be held true if AI is odd. Okay, so if you don't get this, let me explain this with an example. So let's take let's say 7, right? Or no, okay, let's take 11. So if you take 11, now let's subtract 1 from it. So what we will get? We'll get 10 and 10, right? Now make this 1010 as x. So our x plus 1 will be this. Now if you take x or x plus 1, what will be the answer? Okay, if you take OR of this, 1, 1, 0, 1. Now you can see we get the same number as x plus 1, which was our AI as well, right? Which was our AI as well. Okay. So for every AI, the answer will be at least x. Okay. The maximum answer will be x. But we want to find out the minimum one, right? Here, the problem statement says that we want to find out the minimum such x. You see, we have to minimize each value. Now, to minimize each value, we want to find out, some kind of pattern, like what happens when you perform this operation, x or x plus 1. Now, if you say, I mean, okay, let me, debug this. For this x will remain x as it is. We cannot say anything about x. But for x plus 1, we can say something, okay? So if you know this property, you will be able to solve this problem. Like, okay, if if there is any number, let's say, whose binary representation is something like this, and we add 1 to that. The binary representation of 1 is itself 1, okay? So 1 gets 0. Okay, then we pass 1 over here, we carry 1 over here. Again, this becomes 0. We carry 1 over here. Again, this becomes 0. We carry 1 over here. And this becomes 1. And on the left hand side, let's say there were, any number of bits. Those will be as it is. Okay. So if you see what has been happened to this number after adding 1, okay? After adding 1, what has happened to this number is you can see that the rightmost 0 was set and the trailing ones were become 0, right? Okay, so this has happened. So we can put this statement that, so our observation is that every rightmost bit, I mean, I should not say every here, okay, rightmost bit will be set, I mean, which was unset in the number, okay, which was unset in the number x. So I should write properly like this. In x plus 1, the rightmost bit will be set, which was unset in the number x, okay. So the and all the trailing ones will become 0, okay. As you can see, this bit, okay, let me highlight, this bit got converted to 1, okay, because it was the rightmost unset bit. This was the rightmost unset bit, okay. Now we want to, this was x, right? And this is our x plus 1. Now if we take OR of this, what will happen? Let's take OR of this, okay? Let me erase this. If we take OR of them, what will happen? Let's ignore x for now, okay, because the answer might differ. So the OR now will be, if you take OR of these two elements, like 1 0 triple 1 or 1 1 triple 0, 1 1 triple 0, right? If you see this, this is set, this is set, this is set, this is set, all of them were set. So what happened here was, like in x, those bits which are set, all of them remained set in the final answer. But that one bit which was the rightmost unset bit, it got set in x plus 1. That's why it also got set in the final answer. Okay. Uh, if you don't get that statement, please go backwards and see once again. We will see one more example and then we will jump to the solution. Okay. let's see, let's say if we had this binary representation. Okay, I guess it is the same as previous, so let me do something like this. Okay, we don't know if it is prime or not, but okay, for let's say this is our binary representation. So what, let's say this is our x, okay, and this is our, I mean, okay, this is our x. Now what will happen if you know, if you add 1 to x, so x plus 1 will be, as we saw that, this is the rightmost 0, this will become set, okay? So our answer will, our x plus 1 will be this thing. You can try it by yourself by adding x plus 1, by adding 1 to the x. So now if we take OR of this, OR of both of these elements, what we will get? 1, 1, 0, 1, 0, 1. As you can see, every element which was set in this x is already set in the final answer, right? Uh, okay, except for this bit, okay? Now this bit, if you see, this was the rightmost unset bit and it got set in the final answer. So we can infer some observations over here. So what can we do? Let's say we want to find out, our final answer should be AI, right? Let's say the representation of AI is something like this, okay? Okay, let me take some leading zeros, trailing ones, okay? So what we can do now is, okay, we want this number to be as our final answer, right? So as we know that we can set at most one bit, okay? So I mean, as the in the final answer, let's assume that this is our final answer. We can, after getting x plus 1, we can set at most one bit over here, okay? So let's say that bit was this thing. I'm just assuming if that bit was this thing, okay? If that bit was this, I mean, first bit, okay, 0, 1, 2, 3, 4, 5, 6, and 7. If it was the first bit, then how do you, make, how to make x from it? How to make x from it? Now, okay, we want to, this will be our rightmost unset bit. That's what I'm saying. This will be our rightmost unset bit in x. So which gives us x equals to, every bit will be the same, okay? Every bit will be the same except this bit. This bit will be unset in this, and this will be the rightmost bit, which is unset, okay? Now, uh, okay, now what you can do is, if you see, if you add x plus 1, if you take x plus 1, we saw that this bit will get set again. So our binary representation will become this thing, okay? Now if we take OR of this, we'll get the same number as AI, okay? So that means we have found out such an x where AI is, we got x, or x plus 1 is equal to AI. Now here we just took this bit, right? What if we take other bits, right? It will also work for this bit, and it will also work for this bit, okay? Because we can, set this bit 0, and then it will be the rightmost unset bit, and it will be set in the x plus 1, okay? So, but if you take for this bit, okay? So of course you will choose the set bit only, right? Because you will need to have that set bit in the final answer. So you will only unset the set bit, okay? So you cannot work with 0, you cannot work with 0. Now if you try to change this bit, okay, if you say I can make this as, set, I can unset this bit, then it will not work. Let me show it why. Because what happened here is, now let's say for this one I took 0. I'm constructing x right now. Everything else will be the same. Okay. Now if you see, okay, let me take x plus 1. The x plus 1 becomes, I mean, sets this bit, right? It sets this bit, and we never get our answer. We wanted this bit to be set in our final answer, but we got 0 over here. Okay. So that means it doesn't work. Why it didn't work? Because there was already a 0 present in the AI, which was the rightmost one and which was already set. Okay. So that means we cannot work upon that. So all we care about is the trailing ones. Okay. All we care about the trailing ones. Now we want to find out the smallest. So we can unset any of these ones, right? So if there can be multiple ones, we can unset any one of them. So which one should you take? So as I said, the problem statement asks us to, minimize this x. Okay. And if you know some, normal bit logics, so you will say that I will always choose the leftmost one, which was I mean, which will be set 0 and which will make my x minimum possible. Okay, like this one creates a difference of what number? It will be 2 raised to 0. This will create 2 raised to 1. This will create 2 raised to 2. This will create 2 raised to 3. But this will create 2 raised to 5 difference, right? So that will gives us the smallest x. Okay, so we will always choose the left leftmost set bit from the right. Okay, so our logic is, our approach will be unset the leftmost set bit in the trailing ones. Okay, so let's take some examples. So if I go here, let's find answers for 2 3 5 7. Okay, as we saw that for 2 the answer will not exist. So let's take for 3 5 and 7. Their binary representations is 1 1. For 5 the binary representation is this. For 7 the binary is this. Now what is the leftmost? So this was the leftmost trailing one, right? So we can unset it. So our answer will be 0 1, which in decimal becomes 1. For this one, we can only unset this bit. So this becomes 1 0 0. That is, our answer is 4. And here we can unset this bit, which gives us this number, which is binary representation of 3. So 143 is our answer. Let's see if that's correct. We can see 143. Okay. So our logic is clear. We just want to find out the rightmost, from the leftmost trailing one and then unset it. Okay. So let's go through the code. Here I have created an answer vector. We just loop through the nums array, and then if we in our nums of I is 2, we simply push back answer. We simply push back -1. Let me make like this for better understanding. Okay. Now in the else part. Okay. Now in the else part, we have to find out from the right what is the leftmost one, and we have to unset it. Okay. So let's store the nums of I in x. So now this is the bit. Okay. Now while my x is greater than 0 and I get, and my lastmost bit is 1, This is just checking if my last bit is 1 or not. If you don't know if any odd number has its last bit set, you can always write something like this instead of that. So if this is it, if this is the case, that means that I have the trailing ones, so I can right shift that. Okay, so I can right shift the X and continue my process, and I will also track the bit. Okay, so this will give me the leftmost zero, leftmost unset bit. Okay, I mean the rightmost unset bit. Okay, so once I got the rightmost unset bit, how can I get the leftmost one over here, right? So it will be just on the right side of it. So we'll decrease this bit. As you know, the bit indexing starts from the right to left. So it's generally like this, 4, 5, 6. Okay. Now let's say for at index 3, I got up till index 3, I got, all ones after this, and here I got 0. So my B will be 4 out when it is out of the loop, because when we get the last bit at 0, I'm breaking it. So now that's why to, compensate, like this bit is unset, right? We want the set bit. Okay, so we will subtract 1 from the B, and then we want to just unset this bit. Now, how to unset this bit? We will use the XOR operation. Okay, so if we use XOR operation, this will just toggle the bit 1 to 0, and we know which bit to unset, right? So this is one left shift B. Now this will be our answer. So it is temp answer. Okay, we'll simply push the answer and a temporary answer and return the answer vector. Now let's run if it works. As you can see, it's working. Let's submit it. As you okay, we got the accepted thing. Also, let me try writing a 0 over here, and we want this bit to be unset, right? So let's AND it with 0. Okay, so 0 will be shifted by B things, and okay, somehow it gives me the wrong answers. What if I use, not of this? What will happen? Let's check. This should not happen, but okay. Maybe you can search upon it, like why it doesn't work. Okay. But anyways, you got the logic. Thank you so much for watching.